Refrigeration cycle. The refrigeration cycle is the heart of cooling systems. It works on a simple principle. A refrigerant absorbs heat from one place and releases it to another. The evaporator absorbs heat from the indoor air and turns the refrigerant into vapor. The compressor compresses this vapor, increasing its temperature and pressure. The condenser then rejects this heat to the outside air or water. Finally, the expansion valve reduces the pressure of the refrigerant and sends it back to the evaporator to start the cycle again. This continuous cycle keeps our homes, offices, and industries cool. Types of refrigeration systems. In HVAC, we use different refrigeration setups depending on the requirement. Split air conditioners, commonly used in homes and small offices. They are simple, efficient, and easy to install. Water-cooled chillers, used in large commercial buildings and industries where big cooling capacity is needed. They use water as the cooling medium. Cooling towers, work with chillers to remove heat from water. Mostly used in high-rise buildings, factories, and power plants. Each system has unique applications, but the principle of refrigeration remains the same. Refrigerant handling. Refrigerants are the working fluids of HVAC systems. But remember, they can be harmful to the environment if not handled properly. Recovery, collecting refrigerant from a system before repairing or decommissioning. Recycling, cleaning refrigerant for reuse in the same system. Reclamation, processing refrigerant to meet new product specifications for reuse in other systems. Technicians must follow safety guidelines and environmental regulations to prevent ozone depletion and global warming. Ductwork design. Once cooling is produced, it needs to be delivered to the right spaces. This is where ductwork comes in. Proper duct sizing ensures correct airflow. Insulation prevents energy loss and keeps air at the right temperature. Designing duct layout carefully reduces airflow resistance and improves efficiency. Good ductwork design means lower electricity bills and better comfort. Air balancing. Air balancing ensures every room gets the right amount of cooled or heated air. Balancing dampers are used to adjust airflow. Without balancing, some rooms may be too hot, while others are too cold. Regular testing and adjustment of airflow makes the system efficient. Balanced air equals comfortable living environment. Ventilation. Ventilation is all about fresh air. It helps maintain good indoor air quality by removing stale air and bringing in fresh air. Mechanical ventilation. Fans, ducts, and exhaust systems used in modern HVAC systems. Natural ventilation, using windows, vents, and natural airflow. Good ventilation keeps the air healthy, reduces indoor pollution, and prevents buildup of harmful gases like CO2. Conclusion. So today, we learned about two key topics in HVAC: refrigeration systems and air distribution. Refrigeration explains how cooling is produced, while air distribution explains how that cooling is delivered and maintained inside buildings. Together, they form the backbone of every HVAC system.